Is a foldable over all of the quadrilaterals, and remember in 5th grade you should have learned some geometry, and a quadrilateral is any four-sided figure. So in this first fill in the blank in the top right, it says a quadrilateral is any, and the answer is 4. So you're talking about squares, rectangles, and then there's other types of quadrilaterals that you'll see in this. This is a foldable, so it involves like some cutting, and then you'll fold. I have a picture of it on the front of the classroom if you just want to look up there and make yours look like mine. But we're going to start with an actual parallelogram. So a parallelogram is essentially like a rectangle that looks kind of like someone pushed it over. So the formula for the area of a parallelogram is just base times height. It's essentially just the same formula to find the area of a rectangle. It's just rectangle is length times width, whereas a parallelogram, it's base times height, but you still just multiply the two numbers together. So in this example, we have a base of 14 centimeters and a height of 7 centimeters. So we're going to do 14 times 7, and let me pull up a calculator. So 14 times 7, 98. And for some reason, area is always in squared units. Well, there's a reasoning to it, but 98, and since it's centimeters, we're going to do centimeters. And squared is just an exponent of 2, so the little baby 2 up at the top. Now, if you look at the front of your foldable, it tells you the properties of a parallelogram, and a parallelogram has opposite sides that are congruent, meaning opposite sides are the same length, and then two sets of parallel sides. And parallel means that they could go on forever and they will never touch. So like they will never intersect and cross each other. And then back to this, the next shape I'm going to do is, let's just go to the trapezoid. A trapezoid is this shape. It's four-sided because all quadrilaterals are four-sided. It just has some different properties to it. And the formula for the area of a trapezoid is the most confusing out of all of them. It's base 1 plus base 2, and then after you add them, you have to divide it by 2 and then multiply it by the height. So I've said right here that B stands for base. And if you look at this purple trapezoid, you can see that base 1 is just the length of the top, base 2 is the length of the bottom. After you add those two numbers, you divide it by 2 and multiply it by the height. So like I said, it's not that it's confusing, it just has the most steps. So let's do this example. It's base 1 plus base 2. So we need to add the base 1, which is 17, plus base 2, which is 39. So pull up my calculator. 17 plus 39. Once you total them, you have to do this step, which is divide it by 2. So take the answer, divide by 2. And then you do the last step, which is multiply it by the height. And the height on this trapezoid is 16. So times 16. And the answer is 448. And remember, it's always in squared units. So 448 looks like we're talking about feet squared. Okay. And the properties of a trapezoid is just one pair of parallel sides. So if you look back at the thing, the parallel sides are the base 1 and base 2. Let's go over to the rectangle. That one's really easy. It's just length times width. And length is the bottom, width is the side. So on this one, we have a length of 9 and a width of 4. So 9 times 4 is just 36 centimeters squared. And the properties of a rectangle are opposite sides are congruent, so opposite sides are the same length. And then there's two sets of parallel sides, meaning the widths are both parallel and the lengths are both parallel. It also has 4 right angles. Now let's go down to the next two shapes. And we have a rhombus, which is kind of like a kite, and then a square, which is an easy one. So on a rhombus, which is the thing that looks like a kite, they call the lines that cut through it diagonals. So the formula is diagonal 1 times diagonal 2, and then take that answer and divide it by 2. And I've said right here that D stands for diagonal. So if you look, the diagonals are just the lines that literally cut straight through the middle, and they intersect each other. So on the example, the purple rhombus, one diagonal is 11 and the other diagonal is 18. So with the formula, we have to multiply those together and divide the answer by 2. So 18 times 11 equals 198, divide it by 2, and it equals 99. And this one is in inches, so 99 inches squared. It's hard to write with this. All right, and the properties of a rhombus. All sides are congruent, so all sides have to be the same length, and opposite sides are parallel. Okay, and a square. So a square is essentially the same as a rectangle. You have to multiply the two sides. The thing that's special about a square is that all sides are the same length. So the formula for it is just to take one of the side lengths and square it, because 6 times 6 is the same thing as saying 6 squared. And 6 squared is 36. So in this case, it's 36 feet squared. And the properties of a square is that all sides are congruent, 2 sets of parallel sides, and it has 4 right angles. So make sure you've got all of this copied down. You're going to want to keep these notes because you're going to need to use them tomorrow as well, and then glue them into your notebook.